afternoon and welcome to our summer series HMSee webcast. Thank you for joining us for this special broadcast covering Linux on C and Crypto Express cards. This Learning with Lattes production is moderated by Marie Ashway, Director of Marketing of Mainline.
Thank you. We're going to talk about the use of Crypto Express cards when it comes to Linux on Z. We have a fairly straightforward agenda today. We'll focus on how to implement these cards and how to get them configured. There will also be a demo showing some of the benefits of setting these up to do SSL and TLS type traffic. We'll answer questions at the end. I would imagine a lot of you have already heard about pervasive encryption and how it is set around encrypting your data, both at rest or in flight. These Crypto Express cards are a major part of the plan to do that. Let's first explain what these cards are. Crypto Express cards are physical PCIe I/O cards that do various cryptographic functions. You can have up to 16 of these cards on a Z14 and Linux One. Initially, when ordering, these must be ordered as a pair. And from there, you can order them in any quantity, up to the maximum. The cards are set up to be shared across all of your active LPARs. They're set up with what they call domains, which allow you to use these cards for your different LPARs. The Crypto Express cards can be set up primarily in 3 different ways. When they are initially installed, they'll usually come as a common cryptographic architecture, a CCA coprocessor. They can provide a FIPS 140 environment, as well as many other functions. It can also perform as different types of coprocessors. Here, you have it as a PKCS number 11 coprocessor, which is used to meet different industry requirements. Today we're going to focus on the card when it's used mostly as an accelerator. This is used a lot for SSL and TLS processing to help you offload processing from your IFLS and CP engines. The crypto cards support a large number of different functions. They support over 300 different algorithms and modes. While in accelerator mode, keys up to 4096 are supported. The different cards have different capabilities and strengths. For example, when they are configured as an accelerator, they provide the best performance when you're referring to SSL and TLS type traffic. When they are configured as coprocessors, they're more geared towards asymmetric encrypted key processing. The CPAC-F, which is the CP assist for cryptographic functions, provides the highest symmetric clear key encryption performance. As far as configuration or setup goes, multiple cards may be required depending on your configuration. Beyond your initial 2 cards that you need to order, you can have several sets of these cards for performance, some set up as coprocessors and others as accelerators. Crypto Express cards provide a tamper-resistant responding repository for various types of keys used for encryption and decryption. There is one prerequisite for using these cards. Crypto Express cards require that the CPAC-F be enabled on your IBM Z. This feature is ordered with your system. For those of you who may be unfamiliar, this is a crypto card. It looks like any other PCIe card. It is used for encryption, decryption, and other activities. Here, the CPAC-F function is sitting next to your IFL or general purpose engines on the actual processors themselves. I mentioned the TKE station here. This, again, is used when you have the card configured to enter keys or for backup purposes. There are 3 different elements that have to work together here and must all support the algorithms you wish to use. Now, let's move to our demo. Thank you.
This presentation, basically, we have a couple Crypto Express cards on our processor, Z14, ZR1. They're Crypto Express 6S's. Those are the most current versions available. And I've set them up so that we can kind of demonstrate the offloading that takes place when you're doing SSL and TLS processing. The presentation is kind of centered around what it takes to set up this in a ZVM and Linux environment. And the presentation is kind of geared towards a newly installed these cards, basically what you need to do. If you have existing cards or you want to change card type, for example, to something else, like change it from a coprocessor to an accelerator, you'll have to use slightly different procedures. Some of these procedures are disruptive to the card, so you'll have to be careful there. I haven't mentioned much about setting these up to be used with KVM or Docker. I have left you some links, though, on the reference chart that should point you in the right direction, at least to get you started if you want to look at using these cards in those environments as well. And I guess the main point of this presentation is why does this make a difference? And the easiest way for me to show you that is, some results here. And this is from a ransom benchmarking tests. And these basically, it's just a free benchmarking tool. It's an Apache benchmarking tool that allows me to tell how many, connections I want to start, how many I want to have at the same time, and then what type of cipher suite I want to use when I'm doing, from browser to web server processing. And if you look on the left, you'll see this test that was run with a Linux guest that did not have Crypto Express cards available to it. Quite a significant amount of CPU is being used, and realized that was being used strictly for the encryption and decryption. And so any other work on that Linux guest, for that matter, on the VM system or anything that was sharing those IFLs, competing with that. You look to the right here, you'll see that this was the same exact test, the same parameters and everything. This just happened to be run on a Linux guest that had access to those crypto cards. And quite a significant difference. Barely over 1% of CPU is being used. And obviously, different workloads will have different, results, and different cipher suites will have different results. And I'll show that a little later in the demo. But there is quite a significant difference here. You can eliminate a lot of this workload, and you can use your IFLs to actually process real workload as opposed to just doing cryptography. So we'll start from a hardware standpoint, and I'll go through this fairly quickly here. But basically, when your CE comes in, he or she is going to physically install these cards, and then you're going to be able to actually configure them. Configuring them from the support element isn't really that difficult. Like I said, there is a prerequisite here. You have to check and make sure that you have the CPAC-F feature installed. This screenshot here shows you how to do that. Fairly easy to verify. From the rest of this configuration, all these screens come from the support element. So you'll have to get into single object operations to go ahead and do all this configuration. What you'll see when you're in the support element, you can go over and look over on the left here. You'll see under cryptos here, under the cryptos tab. If you click on that, you'll see the number of crypto cards that you physically have installed, whether they're online or standby, and what type they are. And then in order to configure these to be used by the different LPARs that you have, the easiest way to do this is to get into tasks index and then filter on it, and it'll bring up 6 different configuration functions here that allow you to do various things with these cards. The first one we're going to look at is the cryptographic configuration. And what this allows you to do is it allows you to change the type that you're actually running. So you'll notice in this screenshot here, I've got the first one here is a CCA coprocessor, and the second one's an accelerator. I'm going to go ahead and change. I'll show you the flow for changing this CCA coprocessor to an accelerator. It's not very difficult. The important thing here is when you change the mode of these cards, they have to be in standby mode, basically varied off, and then they'll be changed and then varied on to take effect. So basically, just like you would configure any other chiplet online or off, process is just to get to the configure on-off function and select the cards that you want to, or select the P-chippets you want to use, and go ahead and configure them off. After that, you're going to see that the one that I've got is stopped, and I can now go in and make a change to this, change this to an accelerator. Remember, this is disruptive, so anybody that was using this card you've disrupted them. So if you get back into the crypto configuration function here, you can go ahead and with the crypto type configuration, select that, and it'll come up with a screen that gives you the option to select the 3 different modes. We're going to put it in accelerator mode. The zeroize the coprocessor basically means it's going to wipe out any keys that were in the coprocessor at the time. So I want to be careful with that. It'll go through and ask you to verify that you want to do this. And then it'll come back and tell you that you're now in accelerator mode out of this, and it'll come back and say you now have your type is now changed to both of those are accelerators. But you'll notice that it's deconfigured, so you'll have to turn it back. You'll have to basically vary the chiplets back online. While you're doing this, it'll show initializing as it's coming back online. And once it's finished, you'll basically be able to add the different LPARs or carve up the LPARs the way you want to use these crypto cards. And you do that with the change LPAR crypto configuration. This is an LPAR by LPAR function, so you'll select whichever LPAR you want to work on. In this case, I'm selecting one of mine here. And then you'll get a screen that looks like this, and this is where you get to choose which cards that LPAR has access to, and then which index. Again, I said earlier that depending on how many LPARs you have on the system, you'll have the number of domains or indexes here. You can, if you have a lot of partitions, it may be a 1-to-1 ratio. You may have other needs, though, where you have multiple indexes configured for one LPAR. For example, if you were going to dedicate these resources to a particular user or something like that. But the only thing you have to remember here is that all the active partitions have to have unique card and domain settings, and I'll show you that here in a minute. Once you get done configuring this, if you do a save and change button, save and change task, what that allows you to do is it'll dynamically make the change as well as it saves the settings into your LPAR image profile, so that that'll be permanent. So the next time you reset that partition or whatever, you won't lose your changes. So this is just a picture of what you'll see if you looked at your image profile under crypto. You'll see the same thing you saw on the previous screens there. If you want to take a look overall as far as what all the LPARs have available to them or how they've been configured, you can use the View LPAR configuration controls, which will show you a screen similar to this. So you'll see that I've got on the first pane here, on the top pane, it shows me my indexes, or it shows me the cards I have available to me. So I'm using both of them, 0 and 1. For this particular screenshot, you'll see that like the partition IT only has access to the card 1. Then on the lower screen here, or the lower panel here, you'll see the indexes that I gave access to. And it'll show conflicts over here. You have other partitions that have the same configuration. And again, you'll be fine as long as all your active partitions are unique, but you may have conflicts. For example, if you have, for example, backup partitions or something that you would never have up at the same time, you could have a legitimate conflict there. And that's pretty much it. Trust me, it took longer to explain than it actually does to implement. As far as the VM configuration goes, very simple. In this particular demo and demonstration here, I'm basically using a ZVM 6.4 system. I will tell you about one caveat, though, that ZVM will require that will require an IPL so that you can recognize the new cards. It's one of their features they're working on, so in the future it should be dynamic. There's not too much to do with the configuration as far as VM's concerned. You're going to tell VM which cards it has access to, so you'll do that through the crypto AP vert or crypto AP dedicate commands. As far as today, since we're running this in accelerator mode, we're just going to use the crypto AP vert, which will allow VM to dynamically choose which crypto resources to use. What you'll see when you're configured this way is that from a Linux standpoint, your Linux guest is only going to see one card. Even if you have 2 or more available, you'll actually use both of those cards. Linux itself will only see one. The crypto AP vert, as far as the Linux guest definition goes, can be either put in its individual directory entry, or it can be put in a common profile if every Linux guest needs access to those crypto cards. This is an example of how this system happens to be set up. I'm in an SSI cluster right now, so I've got both of my VM partitions configured here, and you'll notice that it was the same type of information you saw on the screens earlier. So with the AP definitions here, those are the cards themselves, and then the domains or the indexes that I had earlier in the presentation. So fairly straightforward. And as far as the actual definition for the Linux guest itself, it's just crypto AP vert definition. And again, you can put it in the individual directory entry, or you can put it in like this Linux default profile if you had this in all of your Linux guests. And from a viewing the resources, it's really simple. You can do a qcrypto. That'll show if you have the crypto cards available to VM, it'll show as installed or not installed. And then you can do the crypto domains users, which will show how they're configured. So you'll see that I have both cards here and both of my domains, and they're shared. And then if you have a particular user that has access to these, and you do this command, you'll see that that user shows up as shared. And that's pretty much it for VM. And then from a Linux standpoint, very simple to set up. Again, for the demo today, I've got, we're going to use 2 systems out of here that I've set up. Basically, they're identical. They've both got 4 processors. They both got 4 gig of memory. They both have the same software level. The only difference is one of them has access to the crypto cards and the other one doesn't. I happen to be picking on Red Hat today. I could have picked on SLES or Ubuntu. It doesn't matter. The setup's pretty much the same on all three distributions. I've given you examples of all three distributions here in these next couple of slides. And there's some good documentation I've referenced in the reference slide that'll talk about even older releases if you want to go back a little bit. So basically, it's very simple to implement this under Linux. You're going to install a couple packages that are required, like I mentioned earlier, the live ICA and OpenSSL IBM-CA packages. OpenSSL and OpenSSH should already be installed on your system, and then the zcrypt should already be there as well. And then you're going to modify the OpenSSL configuration file. You're going to basically add a statement to near the top, and then you're going to copy an existing sample file at the bottom of the config file that will allow you to take advantage of these the crypto cards. And again, this is an example of what you do with SLES. You'll see that it's the same process. The package names are a little different. The location of the OpenSSL config file is a little different, but it's the same idea. And same thing with the Ubuntu release. Once you get done making these changes, go ahead and shut your guest down and bring it back up, and you should have access to the crypto cards and the CPAC-F coprocessor. And that's it. So it's fairly straightforward, fairly easy to configure. I'll kind of go through a little bit about how to display usage and see if you've got things configured properly under Linux here. There's a couple different commands you can use. There's the ICA info command, which will show you which functions can be executed as far as hardware and which ones are done in software. What you're looking for here, I've highlighted in yellow. When you see the RSA-ME and RSA-CRT, you'll know that you've got access to the actual crypto cards themselves. You can also do various displays on the driver itself, so you'll get information such as what type of crypto card it is, the status, whether it's online or offline, and then requests and stuff like that. And you'll notice that it only shows one card here, but it actually has access to both of those crypto cards physically. And a couple of different displays here, some additional information. And it tells you what the bottom one here tells you what the card provides as far as capabilities and that go. And just an additional display tells you which, from a Linux standpoint, which card and domain is being used. There's also an ICA Stats command that can be used for both display and also reset. So you may want to reset your statistics. For example, if you were doing testing to verify that you were, doing hardware, the actual encryption decryption was being done in hardware as opposed to software, and which functions were actually. You can also do additional commands here to give you similar information. If you look at the actual files associated with the cards, you'll see much the same information you saw in some of those other displays, such as the requests and various stuff like that. So the same type of information, just a different way to get at it. And again, this is an ICA Stats, shows you various statistics as to what the card was actually, what the card and the CPAC-F features are actually doing. And that's pretty much it as far as what you can see from Linux. You can also take a look at this from the HMSee. If you get in and look at the monitor's dashboard, you'll be able to select, after you select details, you'll be able to select on adapters, and what you'll see is your crypto adapters will come up, and you'll select both of them. In this case, it's add two, and then you'll end up looking at a screen that looks similar to this. And this it's just a historic screen, and it'll sit there and run forever. And you can monitor the cryptographic card usage on both of your cards. You can also offload this data into like a CSV file for further processing if you want. So basically, with that, we can do the demo. I know that was kind of quick. I kind of wanted to more emphasize that this is a fairly easy thing to implement. It has a lot of benefits. Basically, like I mentioned before, I'm just using it's a free tool. It's a Apache benchmarking tool, and what it allows me to do here basically is to dictate how many connections I have to my Apache website, and how many of those I can process at the same time. and then it allows me to dictate which cipher suite I want to use for that particular test. So I realize that this is a benchmark, but it's an easy way to get an idea of what you possibly might see in your environment if you have similar characteristics. So just to kind of explain this test, I'm going to run it for 15,000 requests. I'm going to send 100 of requests at a time at my website, and then the cipher suite I'm going to use for the benchmark. And I have a breakdown here of what they mean here. So what you'll find is that the different cipher suites that you use will have different effects on the CPU utilization. So in this particular one, you're going to see very high utilization on the CPU, and then very significant reduction when you use the actual crypto cards themselves. We're going to do a second test just to show you kind of the difference. In this particular test, this is an elliptical curve cipher suite, and it's going to use significantly less CPU, but it will use the reduction. It still uses some CPU even with the crypto card. So you have to choose the best cipher suites that are right for your shop, and you're going to have probably a range of them that you'll prioritize and use. So you may you'll see different outcomes depending on which cipher suites that you actually use. I'm going to go ahead and take this out of full screen here and pop over here. What you'll see here is just a top. I've got top running on my Linux-based system. This is a system that doesn't have any crypto cards on it. I've got another system here, this RH Crypt system. This is the system that has the crypto cards available. And then I have for my laptop, I'm going to run these tests. So it's basically, it's from a browser to a website that you would normally see in an environment. To basically start this test here, go ahead and run this. These won't run that long. I just kind of wanted to show you what this looks like here. So we'll start the test here, and what you'll see is I started on my system that didn't have the crypto cards, and basically what you'll see is the processing has climbed significantly. And you'll see that we have a lot of processes here for the Apache web server, and it's going to climb into the 70s here. And then if I look at my display on my crypto cards here, I'm not using the crypto cards, so this is going to be flat all the way across. You'll see that both of them will be the same. That also is true when they're actually being used. They're used pretty much in conjunction with each other. The test here won't run that long, but basically, this is significant. Depending on how large your environment is, this could utilize quite a lot of CPU resources. So if you have a large web serving environment, this could be very beneficial to offload this processing. And again, you can have multiple cards. I'm demonstrating we have 2 on our system today. You could have more than 2. But again, when you're processing this much on this particular server, you also have to understand that you've got this is going to slow down other Linux guests if you're sharing the processors across VMs or across LPARs. So this should be finished here in just a second. Just a minute. And almost done. And then what we'll do is I'll show you what it looks like on the same exact test on a system that doesn't have or that has crypto cards. So let me go ahead and start this up. Same test, just a different Linux guest. What you'll notice is, I've got a lot of the Apache processes running here. I'm barely getting above 1%, so quite a significant difference. And again, the mileage will vary depending on your workloads and which cipher suites and stuff you're actually using. And if I take a look at the crypto cards here, give this a second here, you'll see that this spikes up. Give it a second here. It's in 15-second intervals here. So this usually, depending on your workload, this may stay steady or it'll fluctuate all over the place. Again, you can export this data. So if you wanted to, analyze this later on, you can actually do that. But you'll notice that the usage on these cards has spiked up, and you'll see that both of them, because I have them shared in this particular environment, they're both going to be running about the same here, same percentage utilization. And basically, it's just, like I said, it's barely getting above 1%. So that means you can actually do other work on the IFLs, and your other guests aren't being impeded by this processing. And this should be finished here in a second. And then we'll just do another quick test, and we should be done at that point. But I hope that I've basically just shown you, one aspect of what these cards can be used for, and these cards can be used for so much more. But I think it really demonstrates their capabilities and how they can be used. At this point, the test is finished, and you'll notice that that will eventually drop down. But if I ran this with a different cipher suite, you'll see that I get somewhat different results here. Go ahead and so again, this is just on the base system, no crypto cards, and basically see similar results here, but my this particular combination of the cipher suite and stuff doesn't have the same impact on the processor. So it's like I said, you'll have different results based on which cipher suites that you use, and then it will also, the other characteristics this test will run in this particular case runs for a lot less time than the other tests. So I would choose your cipher suites that you want to use and then test it accordingly. And this should be finished here in a second, and I'll show you what it looks like. Sorry. Yep. And I'll show you what it looks like on the one with the cards. And you're going to see similar results. However, you still are doing some CPU processing based on the suite that you used. So different characteristics. But you also notice that on the actual card itself, you don't get quite as much utilization. And this shouldn't take that long to finish up here, and then I'll conclude. And I'll open it up for questions here in a second. And this will spike up a little bit, but again, it won't be anywhere near the other test. But basically, both cards are going to use the same. Will be shared, so they'll use the same amount. It'll be the same capacity on each card. So at this point, Um, test is over. So pretty much that's really all I wanted to kind of demonstrate, just to kind of show you the difference and what you might be able to achieve. Again, like I said, your results may vary, but it was a good way to kind of demonstrate the offloading capabilities of these cards. Here's the reference chart that I mentioned. Basically, the first four here references. There's a couple red books in here, and then there's a couple good documents that go through how to actually set up the Linux guests, depending on whether you're Ubuntu or Red Hat or SUSE. The next three here are just basically kind of get you started as far as if you wanted to look at this from a KVM or a Docker standpoint. And then the last one here is just a nice reference on how the cipher suites are kind of broken up. So in conclusion here, basically, I hope this was helpful, and I hope that this was somewhat beneficial. Again, different cipher suites are going to have different results. Obviously, your testing will have different results, but I pretty much discussed what the crypto cards did in an accelerator mode today. But remember that these cards can do so much more. Barely scratched the surface on what these cards can do. And if you don't have cards available to you right now, we're more than happy to set up demos or benchmarks to help you figure out if your workloads or your workload characteristics would benefit from adding some of these cards to your installation. And with that, I think I'm done with my presentation.
We appreciate you joining us for this special Linux on Z Innovation Series broadcast. Need more information? Visit us online at mainline.com or give us a call. We look forward to hearing from you.